Hello students, welcome to today's class. Today we are going to start the exercise number 7.1 which is the first exercise of coordinate geometry. Exercise number 7.1 and the question is find the distance between the following points. There are few points given. We have to find the distance. Very simple formula. Use the formula, get the answer. That's all. The first one is 2, 3 and 4, 1. Now 2, 3, 4, 1. So let me write what is x1, y1, what is x2, y2. The coordinates are x coordinate, y coordinate means x1, y1. The second one is x2 and y2. And the distance formula is distance between these 2 points. Distance is equals to root over x1 minus x2 whole square plus y1 minus y2 whole square. Just use the which implies x1. What is my x1? x1 is 2 minus x2 is 4. So 2 minus 4 whole square plus y1 is 3 minus y2 is 1. So this gives me 2 minus 4 which is minus 2 square plus 3 minus 1 which is 2 square, and this gives me 2 to the 4, again 2 to the 4 which is 8. But root 8 still we can simplify. The value of root 8 is 2 root 2 over. So root 8 is equals to 2 root 2. If you want to find, you can find in this way. 2 4 2 2. So for these 2, I'll take one single number remain which is root 2. So the distance between 2, 3 and 4, 1 is the answer is 2 root 2. Similarly, the second one we can do. Second is, this is the second one. x1, y1 and x2, y2. Apply the same formula. The distance is equals to the distance between the 2 points is equals to, write the same formula, x1 minus x2 whole square plus y1 minus y2 whole square. x1, what is my x1? My x1 is minus 5 minus x2. x2 is again minus 1, which will be plus 1 plus y1, what is y1? y1 is 7 and y2 is 3. So this gives me minus 5 plus 1 which is minus 4 whole square plus 4 square. So first one is 16, second also 16. That means root 32. But if you find root 32, you get 4 root 2 units. So the distance between these 2 points, again what I got? 4 root 2. I hope got it. Now the third one. Let's do the third one. Third one is this is the third one. x1 is a, y1 is b, x2 is minus a and y2 is b. Just apply the same formula. This is the third one. What I am going to do? This is the third one. This is the third one. Distance is equal to this formula only I have to use. But just let me substitute the value. So what is the value? x1 minus x2. What is x1? x1 is a minus, what is x2? x2 is minus a. That means this will be plus a whole square plus y1. y1 is b minus, what is y2? y2 is again b whole square. This gives me a plus a 2a whole square plus, but this gets cancelled, b minus b cancelled, this gave me only 0. So finally what I am getting? 2a whole square, but root square cancel and the answer is 2a units. I hope got it. First, second, third one. So question number 1 is over. Now for the second question. Second question is asking find the distance between the origin and one point. find the distance between the second question. What is asking? Again, he is asking the same. Find the distance between, but the 2 points are different. Find the distance between the points. So what are the points he has given? The first point he has given is origin. First is given origin, and the second point is 36 and 51. So what is the first one? This is the question number 2. Second question. Between the origin and 36 and 15. This is the point. Find the distance between 0, 0 and 36, 15. So might have remembered the distance between the origin and any point is root over x square plus y square. Try to use the formula. This is the origin and this is. So what are the points given? Points are, first is 0, 0 and the second one is 36, 15. But the formula is distance between 0, 0, which is the origin, and x, y is equals to, this is the formula, root over x square plus y square. Try to remember the formula. This formula when to use? If you are going to find the distance between origin and any points, let the point be x, y. The point whose coordinates are x and y. So this is the origin. In that case, I have to apply this formula. But what is my x? X is 36. So 36 square plus 15 square. But 36 square is 1296 and 15 square is 225. If I add, I'll get 1521, which is the square of 39. So now I got what is the distance between this 0, 0 and 36 and 15. I hope you got it. Next question is again. Next question is asking determine few points is given, whether those points are collinear or not. Very important question. Next question is asking to check. What to check? Next question is asking to check whether the given points, he has given few points, and those few points are collinear or not. Those few points are collinear or not. The points are, this is the question number 3. Those given points are, what are the points? 1, 5, 2, 3 and -2, -1. He has given these 3 points and he is asking to check whether these points, they are collinear or not. Now what is a collinear? Collinear means if any points, any 3 points, if they are lying on the same line, in the same straight line, those 3 points are called collinear. So what is collinear? 3 points are said to be collinear if all the 3 points lie on the same line, means on a straight line. But mathematically how to prove? Mathematically how to prove? Suppose these are the 3 points. These are the 3 points, and those 3 points let me write as A, B, C. But if 3 points are given, suppose this first point is 1, 5. B, second is 2, 3, and the third one is -2, -1. Let me take these are the 3 points, that is A, B and C. So what I need to prove, if you want to prove that these are collinear, I need to prove that AB, first I have to find AB, then I'll find BC, distance between BC, then I'll find AC. So the condition is, what is the condition? Just let me write the condition. Condition is if AB plus BC is equals to AC, that means the points are collinear. Remember. So if I want to prove that the points are collinear, what I need to prove? I need to find that first I'll find AB, distance between A and B. Second, I'll find BC, distance between B and C. Then I'll find AC. If the sum of these two, AB plus BC, is equals to AC, then I prove that these points are collinear. So let's find first AB. If I want to find AB, I must use the distance formula only. AB is equals to x1 minus x2 whole square plus y1 minus y2 whole square. But what are the points I am taking? A and B. So x1, y1, x2, y2. AB only. x1 minus x2. x1 minus x2 whole square plus y1 minus y2 whole square. 5 minus 3 whole square. And this gives me minus 1 whole square plus 5 minus 3, 2 whole square. And this is 1 square is 1, 2 square is 4, and the answer is root 5. So I got the value of AB is root 5. Distance between A and B is root 5. Now I find what is BC. I must use the same formula, but the points I have to take is these 2 points, B and C. So again use the same formula, x1 minus x2. x1 minus x2 means 2 minus x2 is again minus, so it will be plus. x1 minus x2 whole square plus y1 minus y2 whole square. 3 minus of minus, that is plus whole square. This gives me 2 plus 2, 4 square plus 3 plus 1 again 4 square. That is 16 plus 16, which is root 32. And root 32 is nothing but 4 root 2. 4 root 2. So this is BC I got. Now I'll find a AC. Again I need to use the same formula for AC also. But my A, this one, and C, this one. x1, y1, x2, y2. So x1 minus x2 whole square. x1 minus x2 means plus y1 minus y2 whole square. So x1 minus means plus whole square, 5 plus 1, this is 5, y1 is 5 and y2 is minus 1, means it will be plus 1. So this gives me 1 plus 2, that is 3, 5 plus 1 is 6, 3 is 9, 6 is 36, and this gives me 45, and 45 if I'll find, I'll get 3 root 5. Now you see what I'm getting. x1 minus x2 4, 3 plus 1 4. Okay, am I getting AB plus BC is equals to AC? I think no. See, what is my AB? AB is root 5. What is my BC? BC is 4 root 2. If I add these two, can I get this one? No, never. So what right? Since AB plus BC is not equals to AC, hence the points are not collinear. So when if the point AB plus BC answer you are getting AC, then definitely those points are collinear. So therefore this question is over. Understood how to prove the collinear? Remember only, this is the condition for the collinearity. This is the condition for collinearity. Try to remember. Now the next is question number 4. Question number 4, what is telling? He has given one triangle. And is asking to check whether the triangle is an isosceles triangle or not. He is asking to check whether the triangle is isosceles or not. Question number 4. Question number 4, what is saying? He is asking to check whether the triangle is isosceles or not. And the points what he has given, that is 5 comma minus 2. 5 comma minus 2, that is the first point. 5 comma minus 2. Second is 6 comma 4. Second point coordinate 6 comma 4. Third point coordinate is 7 minus 2. And is asking to check whether these are the vertices of an isosceles or not. So if this is my A, let A is equals to 5 minus 2. Suppose this is a triangle. If I roughly draw one triangle A, B, C, the first I am taking as coordinates of A. Second one I am taking as a coordinate of B. Third as a coordinates of C. Now let A is equals to this one, B is equals to 6, 4 and C is equals to 7 minus 2. If I want to check these points are the vertices of an isosceles triangle or not, I need to find the sides AB, BC, AC. If two sides are equal, then definitely that is an isosceles triangle. So let me find the sides one by one. AB, x1 minus x2 whole square plus y1 minus y2 whole square. I am finding the side AB. AB means this one, x1, y1, x2, y2. So x1 is 5 minus x2 is 6 whole square plus this is x1, this is y1, this is x2, this is y2 plus again y1 minus y2. y1 is minus 2 minus 4, which is 5 minus 6 is minus 1, 2 minus 4 is minus 6. This is equals to 1 plus 36, which is equals to 37. One side I got as 37. So this is root 37 units I got AB. Now find BC. If I find BC, BC is equals to, again I have to use the same formula, but my x1 y1 will be this one, x1 y1 x2 y2, because I am taking BC. So points of B and C I have to consider. x1 minus x2, 6 minus 7 whole square plus y1 minus y2, 4 minus of minus plus 2 whole square. 6 minus 7 is a minus 1 square plus 4 plus 2 is 6 square. Minus 1 square is 1 only. 1 plus 36, which is again I am getting 37 units. So BC also I got 37 units. This is also I got 37 units. Now let me find the third side, which is AC. AC. So A and C, these two only I have to take. A and C. This is the x1, y1, x2, y2. So x1 minus x2 whole square, 5 minus 6 whole square plus y1 minus y2 minus 2 minus 4 whole square. So what I am getting? AC. Sorry, AC I have to take. Means x1 y1 and x2 y2. This is x2, this is y2. So definitely I have to take A and C. Remember, whenever you are finding A and C, AC, you have to find the you have to take the coordinates of A and C only. So x1 minus x2, 5 minus 7, y1 minus y2, minus 2 minus of minus plus 2 whole square. 5 minus 7 is a minus 2 whole square plus this gives me 0, minus 2 plus 2 cancelled. What I am getting? I am getting minus 2 square. But minus 2 square is what? 4, and 4 is nothing but 2. Now yes, from this, out of these three sides, two sides are equal. Which two sides are equal? Since AB is equals to BC, hence these points, they form the vertices of isosceles triangle. Hence the points forms vertices of isosceles triangle. Very simple, just put the formula, get an answer, use the distance formula, find all the three sides. Out of three sides, definitely two sides will get equal, and hence this is nothing but an isosceles triangle. Question number 4 over. Now question number 5. Question number 5 is nothing but just a case study. Case study means just he is given some situations, and in that situation you have to decide whether what he is given that is correct or not. That you have to decide. Here there are, what is telling, there are 4 friends, they are sitting in a class by the name of A, B, C, D. Question number 5. What is telling? 4 friends by the name of A, B, C, D. 4 friends A, B, C and D. They are sitting in a class, but in a particular order. When they were sitting, 2 friends, they made entry into the class by the name of Chamali and Champa. Champa asked to Chamali, don't you notice that A, B, C, D, they form a square? That means the way A, B, C, D, they are sitting in the class, Champa thinks that if I take these 4 corners, so that means this A, B, C, D, they are forming a square. But Champa disagrees. Chamali disagree. What Champa says? Champa says that A, B, C, D, they form a square. But Chamali disagree. Let's see whether Champa is correct or not. So A, B, C, D. Actually, if you notice the point A, the coordinates you will get. The coordinates of A, what you are going to get? 3, 4. If you notice that the graph, the figure, the coordinates of B, what you are going to get? 6, 7. And the coordinates of C, what you are going to get? As 9, 4. And the coordinates of D is 6 and 1. Basing on these coordinates, we can decide, we can check, we can determine whether A, B, C, D is a square or not. So if anything is a square, that means all the 4 sides must be equal. Exactly. So let me find all the 4 sides similarly. Let me find AB. Distance, again distance formula. x1 minus x2 whole square plus y1 minus y2 whole square. I am taking AB. So x1, y1, x2, y2. x1 minus x2, 3 minus 6 whole square plus y1, y2, 4 minus 7 whole square. 3 minus 6 is minus 3 whole square plus 4 minus 7 is minus 3 whole square. So what I am getting? 3 3 is 9 plus 3 3 is 9. That is root 18 I got. Root 18. But if I find, I'll get 3 root 2. So AB I got 3 root 2. Now let me find BC. But I have to apply the same formula. In case I have to take these two, x1, y1, x2, y2. This will be x1, this will be y1, this will be x2, this will be y2. So x1 minus x2 whole square, 6 minus 9 whole square plus 7 minus 4 whole square, 7 minus 4 whole square. 6 minus 9 is nothing but 3 minus 3 whole square. 7 minus 4 is again 3 square. Again this gives me 9 plus 9, which is equals to root 18, which is nothing but 3 root 2 units. So AB over BC over. Now let me find the CD. CD. Again I have to use the same formula. C and D. C and D. So this is x1, y1, x2, y2. x1 minus x2 whole square plus y1 minus y2 whole square, 4 minus 1 whole square. 9 minus 6 is 3 square. 4 minus 1 is 3 square. Again same thing I am getting. 9 plus 9, which is root 18, which is nothing but 3 root 2 units. Now one side term, that is dA. Apply the formula again, dA. So D and A. So this will be my x1, y1, D and A, x2, y2. So x1 minus x2 whole square, 6 minus 3 whole square plus 1 minus 4 whole square. So what do I get? That is 3 square. What I am getting? Minus 3 square. This is 9 plus 9, which is equals to 18. But root 18 nothing but 3 root 2 units. So what do you observe? Champa is correct or Chamali is correct? Champa is correct. Why? AB, BC CD and DA, all the four sides are equal. AB is equals to BC is equals to CD is equals to DA, and this is the property of a square. All the four sides are equal. Since all the four sides are equal and it is a square, therefore Champa is correct. I hope understood. This is a case-based questions, a situation-based question. That is question number 5. Now the question number 6. Question number 6, what is telling? He is telling to name the quadrilateral. Very interesting question. Name the quadrilateral is very simple. If you know the properties of the quadrilateral, you can name it. Remember, for naming of the quadrilateral, naming of a quadrilateral. Naming of a quadrilateral means whether it is a square, whether it is a rectangle, whether it is a parallelogram, whether it is a rhombus. That you have to name. How to name? If you find all the sides, then only you can name it. If for all I am writing, first I am writing the square. What are the properties for the square? First a square. This is a square. If A, B, C and D. In square, AB must be equals to BC, must be equals to CD, must be equals to D. This one anyhow, all the students, I think all of you might have known. All the four sides are equal. But in addition with this one, your AC diagonal, AC must be equals to BD. Then only it is a square. So if you want to check whether the given figure is a square or not, what to do? You have to find all the four sides, A, B, B, C, C, D, D, A. Because vertices are given already, 4 vertices are given. After finding all the four sides by using which formula? Distance formula only. Then finally you have to find your AC also and your DB also. If this AC and BD, these two are also equal, then only it is confirmed that these points are the vertices of a square. This is the first one. Second one, for rhombus. So what is the basic difference between square and rhombus? If A, B, C and D. The common features for both the rhombus and the square is all the four sides are equal in this case also. That means in this case also AB is equals to BC is equals to CD is equals to DA. In case of rhombus also, this is what? This is your rhombus and this is your square. So what is the common thing? In both the cases, all the four sides are equal. But one thing that is different is your diagonal in case of rhombus will never be equal. This is the slight basic difference between square and rhombus. Square all sides are equal, rhombus all sides are equal, but in square diagonals again equal, but in rhombus diagonals will never be equal. So these two are the basic difference between square and rhombus. So anyhow you have to find all the four sides, but for the clear confirmation you have to again find two diagonals. This diagonal will decide whether the figure is rhombus or square. If diagonals are equal, it is a square. If diagonals are not equal, it is not a square, that is a rhombus. Similarly, the third one is a rectangle. Basic properties of the rectangles you know. The common thing in rectangle is your opposite sides are equal. Opposite. These two sides are equal and these two sides are equal. Means your AB will be definitely equals to CD and AD will be definitely equals to BC. Then that is the rectangle. But in addition with this, your diagonals in rectangle will be equal. These two diagonals will be equal. In rectangle, like in square diagonals are equal. In rectangle also diagonals would be definitely equal. Over. Now, if you take the parallelogram, this is the fourth one. A, B, C, D. In the parallelogram, again, just like in rectangle, in parallelogram, opposite sides are equal as well as parallel. Means AB is equals to CD, AD is equals to BC, but the diagonals are not equal. The diagonals are, you can note down these points. This is the basic things. If you want to check, if you want to give the name, the quadrilateral, whether it is a rectangle or square, rhombus or a parallelogram, this is required. Anyhow, you have to find four sides. Along with the four sides, two diagonals you have to find. Those diagonals will decide the given quadrilateral is what type of it. Now, if all the four sides are different, suppose all A, B, B, C, C, D, D, A, all are different, then it is a trapezium. If all the four sides are different, then definitely the given quadrilateral is a trapezium. So this was your question number 6. Now the question number 7, which is very important. Question number 7. What is telling in question number 7? Find a point on x-axis which is equidistant from 2 points. He's telling you have to find a point on x-axis. That point is equal distance between 2 points. Two given points are given. Question number 7. What is telling? This is your x-axis. You have to find a point on this x-axis. You have to find a point on x-axis. Point on, suppose this is a point on which axis? X-axis. This point is equidistant from these two. ये जो point है ये A P से equal distance में है. Then you ask what is that point? Find the point which is equidistant from both A and B. So the point is on which axis is telling? The point is on x-axis. If the point is on x-axis, your y coordinate will be definitely 0. I think you might have known. If a point is on x-axis, its y coordinate 0. So y coordinate 0. And x coordinate, I don't know, let it be x. Understood why did I take this y coordinate 0? Because he has given the point is on x-axis. If the point is on x-axis, y coordinate 0. If the point is on y-axis, x coordinate 0. So the point coordinates of A is given 2, minus 5. The coordinate of B is given minus 2, 9. Minus 2, 9. So let me find. So according to this question, what I can write? I can write as per question. So what is telling? He is telling that point is equidistant from both A and B. So can I write A P is equals to PB, I think, because P is exactly the center. It's only equal distance. So AP means I must use the distance formula. So what is the distance formula? Distance formula we know. AP means x1, y1, x2, y2. So what is the x1? x1 minus x2 whole square plus y1 minus y2 whole square. This side over. Again PB, distance between P and B. In this case PB. So x1, y1, x2, y2. Now what is x1? x1 minus x2. Minus means plus. Whole square. Plus y1 minus y2 whole square. So which formula applied? x1 minus x2 whole square root over plus y1 minus y2 whole square. Now this gives me, or directly I can use the formula. This a minus b whole square, a square means 2 square. A square plus b square minus 2 minus 2 into a into b. So this first one is a minus whole square, a square plus b square minus 2 plus minus 5 minus 0 means only minus 5. Minus 5 whole square is 25. So left side is your right side. Right side is again a plus b whole square, a square plus b square means 2 square is 4 plus 2 into a into b plus minus 9 square. Second next step what I am getting, 2 square is 4 plus x square minus 2 2s are 4x plus 25, left side over is equals to right side, x square plus 4 plus 2 2s are 4x plus 9 9s are 81. If further I divide, simplify, x square minus 4x, 25 plus 4 that is 29 is equals to x square plus 4x, 81 plus 4 that is 85. Now if I square on both sides, squaring on both sides means there will be no root will be cancelled from both sides. So next is what? A squaring on both sides I am writing. If I do the squaring on both sides, what I am getting, x square minus 4x plus 29 is equals to x square plus 4x plus 85. Now bring all those things from that side to this side, x square minus 4x minus x square minus 4x is equals to 85 minus 29 plus x square minus x square cancel, minus 4x minus 4x is minus 8x. So what we can write, minus 8x is equals to 85 minus 29, 56, or x is equals to 56 divided by minus 8, which is nothing but minus 7. 8 1 is 8, 8 7 is 56. So therefore the point on x-axis, the point on x-axis is what I got, is what I have taken, the point is x comma 0. What I got? I got the x as minus 7 comma 0. So this is the point on x-axis, that point which is equidistant from both a and b. Over. And this is one of the important question. Now the question number is 8. Find the value of y for which the distance between the 2 points is given. Question number 7 over. Now the question number 8. In question number 8, he is asking to find the value of y, one of the coordinate where y is not given. He is telling find the value of y for which the distance between the 2 points. Distance 2 points he has given. Question number 8. The 2 points are, one is the first point is P and whose coordinate is minus 2 comma minus 3, and there is another point which is Q and whose coordinates are given 10 comma y. And what is telling, the distance between these 2 points he is given as 10. That means P is a point and Q is another point. The distance between these 2 points is given as 10 units. Very simple. The distance between P and Q is given. Just find, use the formula, get the answer. So what is given? He is given PQ is nothing but 10 units. PQ means distance between P and Q. Apply the formula. This is x1, this is y1, this is x2, y2. x1 minus x2 whole square. x1 minus x2 whole square plus y1 minus y2 whole square is equal to, he has given 10, or that is minus 8 whole square plus this one. If I expand, what do I get? If I expand 3 3 is 9, a square plus b square minus 2ab minus 2a into b. This is equals to 10. Now what I'm getting? 8 is a 64 plus 9 plus y square plus 2 3 is 6y is equals to 10, or what I'm getting? Y square plus 6y, 64 plus 9 73 is equals to 10. Now I'll do the squaring on both sides because I need to remove this root. So if I want to remove the root, I must do a squaring on both sides. If I do the squaring on both sides, left side the root will finish, means I can write like this: y square plus 6y plus 7 3 it was there. If I want to make it square, squaring on both sides, this square, this root will cancel. It gives me y square plus 6y plus 73 is equals to 10 10s are 100, or y square plus 6y plus 73 minus 100 is equals to 0, and this gives me y square plus 6y minus 27 is equals to 0. From here you have to factorize because I got the quadratic equation. If I factorize y square, 6y means I'll get 9y minus 3y. 9y minus 3y minus 27 is equals to 0. Just factorize. Take the common. Y into y plus 9 minus 3 into y plus 9. I'm just taking the common. Or y plus 9 into y minus 3 equals to 0. Now if I take y plus 9 equals to 0, what is my y? My y is equals to minus 9. If y plus 3, y minus 3 is equals to 0, y is equals to 3. So what is asking? For what value of y? So what is the value of y? Therefore y is equals to, I am getting 3 and 3 and minus 9, means the y may be 3 or y may be minus 9. So this is the value of y. The value of y may be 3 or the value of y may be minus 9. So these are all the questions from the first exercise of coordinate geometry 7.1. So we completed, and the last question, after doing all this, I think the last question you can do yourself. If you're not getting, I'll do, but the first exercise is complete. Now in the next video we'll do the second exercise, which is completely sectional formula. So I'll do the next exercise 7.2 one by one in the next video.